Welcome back to Commander's Tech, Weapons and Warfare in Context. For this episode, we'll resume our exploration of electronic and unconventional warfare by looking at the role of computers, computer networking, and the Internet in modern geopolitics and cyber warfare. The world today is deeply interconnected economically and increasingly socially, and much of this interconnection is made possible and facilitated by the global Internet. Computer networks that were new and novel 20 years ago and virtually unheard of 30 years ago are now so ubiquitous as well as essential to the commercial and financial worlds, socioeconomic organization and administration, that we barely even think about them anymore, even though they make almost everything in our modern lives possible. Computer networks create both a strength and a weakness for modern nations and organizations in the modern world. The communication and coordination they make possible, from logistics to research to social organizing, was simply not possible before, and we all depend on this so much that cyber infrastructure is now a critical national asset to be defended against hostile foreign powers. This is because computer networks create a new target and attack vector for conflict between nation-states, leading to the development of cyber warfare, struggle and combat moving into the digital world. A computer network, at its most basic, can be defined as a group of computers, two or more, with a physical connection, through cables or radio waves, and a logical connection allowing the exchange of data. The logical connection requires that the computers share a common language, what we call a protocol. The principal protocol that has made the global Internet possible is a stack, a family of related protocols, called TCP/IP, Transmission Control Protocol, Internet Protocol. Essentially, TCP defines how computers will communicate with each other, and IP describes the logical relationships between hosts and networks, allowing data to reach the desired recipient. Physically, the Internet is simply made up of all the computers connected to it, but many of those computers perform very specialized roles to make it all possible. The backbone of any internetwork, a network of networks, are the specialized network appliances we call routers, devices connecting multiple network segments together, possessing logic capabilities to direct traffic from one segment to the correct destination segment. Many companies make routers, but the first name in network technology and the first thought of any tech pro when it comes to routing is Cisco. Also important for understanding the basics of the Internet is knowledge of the underlying software platforms that the servers and nodes on the Internet use. Windows, Android, and Mac OS are widely known, but mostly used for end clients. For the actual infrastructure of the Internet, the operating systems needed are Cisco iOS and Linux, although others exist as well, but are more marginal. Cisco iOS is a dedicated, specialized networking operating system that runs on most Cisco switches, routers, and network security devices. iOS is a lightweight operating system optimized for managing resources for packet routing and filtering, and interacted with using a Unix-like command line, implementing most standard network commands and special subsystems for configuration of the physical and logical capabilities of the appliance. For example, configuring the network information on different ports, and building and maintaining routing tables. Linux is the open source cousin to Unix, both of which are central to the history of the Internet. Linux runs on many, many web servers, particularly in the developing world, as Linux is free and open source. In the corporate and government world, Linux doesn't feel free because its arcana calls for specialized engineering talent, which can cost quite a bit. Any discussion of routers also needs to reference the simpler, although still sophisticated appliance, the switch. Switches are similar to routers, but instead of connecting multiple logical networks, they connect multiple physical segments on the same logical network. On any local network, from the smallest home network to a huge corporate office or data center, host machines and servers connect to switches, and then the switches aggregate the connections before connecting to routers, and ultimately the network backbone that we call the Internet. Computer networks have both a logical topology, created by the hierarchy of subnetworks created by the routers and defining the interconnections that allow a computer in Ohio to access a server or site hosted in China, for example. They also, of course, have a physical topology. The traditional physical topology uses copper cables to connect computers, hosts, on the network. Today, while copper cables are certainly still used for the last mile, actually the last few yards, the backbone of a corporate or campus local area network, as well as the public internet, is made up of fiber optic cables which use light pulses to transmit data over glass strands. In addition, wireless networks, both 802.11 Wi-Fi and cellular 4G and 5G, have become commonplace. A more specialized but still vital wireless link is the use of microwave transmission for long-distance network links, including satellite links. Let's take a look at several of the most commonly used networking command line tools. Most of these tools are present on and function the same way on every widely used network-aware operating system in use today. ipconfig or ifconfig. This tool shows off the IP configuration for the host. It shows the IP address of the host, including the network and host portions, the subnet mask, which is a binary string which tells us what part of the IP address is network and what part is host, as well as where our configuration information came from, the DHCP server that provided the address, and the configured DNS servers which provide human-friendly name resolution for remote computers. Ping and path ping. Ping is a tool to send a test message to a remote computer and then report how long it took for the response to arrive. We use this to verify that we can reach a remote computer and identify if there are other issues such as name resolution. Path ping is a more in-depth version of this tool, which shows us the route taken to the remote host, as well as how long each intermediate host took to return. TraceRT or traceroute. Similar to ping, this tool attempts to reach a remote host and then reports the route taken and the time it took. This shows us the routers between source and destination. Netstat. This is a multi-use tool capable of showing a variety of different information, depending on which switches we use. To show open ports, we use netstat-a. Also useful, we can use netstat-r to show the routing table known to the host. Thank you for watching this introduction to computer networks and cyber warfare for understanding the role of computers in modern geopolitical conflict. If you like my content, please make sure you subscribe and keep an eye on, keep up to date on what I have coming out. In the next segment of this series on computer networking and cyber warfare, we're going to take a closer look at the basics of information security and look at some case studies of actual nation-state cyber attacks that have happened in recent years, just to get a little bit better an idea of how this actually plays out in practice. So again, if you haven't already subscribed, subscribe, and I'll see you next time.